Exponential equations using logarithms example 3. Consider the equation p equals 200 times 2 to the power of 0.04 times t. Rearrange the equation to give t in terms of p. Okay, so in other words, we have to solve this equation, so to express t, to find the formula that expresses t. So let me start with the original form of the equation. So it's 200 times 2 to the power of 0.04 times t. Okay, the way to obtain this, the expression of t, is to take the logarithm. So this time I'm going to use the decadic or decimal logarithm, so the logarithm in base 10 of both sides. So let me do that. Logarithm of p should be equal, and since here I have the product, it should be equal to the logarithm of the product 200 times 2 to the power of 0.04 times t. Now I will leave the left hand side without change, so it's the logarithm of p equals, and now I can use the product rule law for logarithms and replace the logarithm of the product by the sum of logarithms. So it's the logarithm of 200 plus the logarithm of 2 to the power of 0.04 t. Okay, like that. Now the logarithm, the first one should be without change, so I just copied it. It's logarithm of p equals logarithm of 200 plus, and since here we have the logarithm of the power, we can use the power rule law to say that it's equal to 0.04 times t times the logarithm of 2, of the number 2 itself. Okay, now we can now try to express t, so we can get rid of logarithm of 200. So we substitute logarithm of 200 from both sides. So we have logarithm of p minus logarithm of 200 equals 0.04 t times logarithm of 2. Now we want t, so we divide both sides of this equation by 0.04 times logarithm of 2. So this gives us the expression for t. T should be equal to a fraction in which we have logarithm of p minus logarithm of 200 divided by 0.04 times logarithm of 2. And this is exactly what we needed. This is the expression for t in this equation. Okay, so this helps us to evaluate the value of t. Now in part B we are asked to find the value of t when p equals 6. So when p equals 6, t is going to be what? So let us use p equals 6 in this formula and evaluate. So it's the decadic logarithm or decimal logarithm of 6 minus the logarithm of 200 divided by 0.04 times the logarithm of 2. Okay, now we may use the calculator to obtain this answer, or what we could have do it here is to try to use the laws of logarithms again to do something with it, but that would not add anything to this solution. So what I do, I just simply plug it into my calculator. So it's logarithm of 6 minus logarithm, I'm using decimal logarithms, of 200, here is the answer, divided by the 0.04 times the logarithm of 2, like that. And the calculator gives me the answer, which is, oh, it's correct. It's minus 126.47. So this is the value, but of course not exact, but just approximate. So therefore I will change this sign to approximately equal. So if t is approximately equal to minus 126.47, then when you plug it into this formula, you get p equal to 6.